Table 130.7c9 serves as an estimated guideline for specific tasks, potentially leading to overprotection. To attain a more precise level of protection, performing an arc flash analysis is recommended. The necessity for a double-layer switching hood arises from the task of working on energized components of panel boards ranging from 240 volts to 600 volts. This activity presents a significant risk, and the double-layer hood offers augmented protection against the arc flash hazard. The notes pertaining to Table 130.7c9 indicate that the hazard risk category is designated as 2*. This signifies that the task is deemed high risk, mandating the use of appropriate personal protective equipment, or PPE. The notes further specify the utilization of a double-layer switching hood to provide added defense against the arc flash hazard. For a more refined assessment of protection, conducting an arc flash analysis is advised. This analysis considers task-specific conditions such as voltage, current, and distance from energized components. It also factors in the type of PPE being used. The analysis outcomes deliver a more precise protection level tailored to the task. When assessing electrical safety, understanding the limitations of standardized tables is crucial. These tables, like Table 130.7c9a, offer general guidelines for selecting personal protective equipment based on voltage levels and task descriptions. However, they are inherently conservative and may lead to the selection of PPE that provides a higher level of protection than strictly necessary for a given situation. This overprotection can result in increased costs, reduced dexterity, and decreased comfort for electrical workers. An arc flash analysis offers a more refined approach to electrical safety. This involves a detailed evaluation of the specific electrical system, taking into account factors such as the available fault current, the working distance, and the duration of a potential arc flash event. By performing this analysis, engineers can determine the precise amount of energy that the worker could be exposed to during an arc flash and select PPE that provides adequate protection without being unnecessarily restrictive. The double-layer switching hood serves as a critical piece of PPE when working on energized panel boards within the 240 volt to 600 volt range. This component addresses the elevated risk associated with this type of work. The energized panel boards are components that, if shorted, will cause the arc flash hazard. An arc flash is a dangerous release of energy caused by an electrical fault. It can generate intense heat, pressure waves, and toxic gases, posing a significant threat to workers in the vicinity. The double-layer hood is designed to provide a barrier against these hazards, reducing the potential for burns, eye injuries, and other serious consequences. The notes accompanying Table 130.7c9 highlight the importance of using the appropriate PPE for high-risk tasks. The designation of hazard risk category 2* indicates that the task requires a higher level of protection than lower-risk categories. It underscores the need for a comprehensive approach to electrical safety, including not only the use of PPE but also proper training, safe work practices, and a thorough understanding of the potential hazards involved. Firstly, conducting an arc flash analysis involves several key steps. The initial step is gathering data about the electrical system, including voltage levels, transformer sizes, conductor types, and protective device settings. Secondly, the next step is this data is then used to create a computer model of the system, which is used to simulate potential arc flash scenarios. Thirdly, the simulations allow engineers to determine the incident energy levels at various locations within the electrical system. Incident energy is a measure of the heat energy that a worker could be exposed to during an arc flash event. Fourthly, the incident energy calculations are used to select the appropriate PPE for each task. PPE is rated based on its ability to withstand a certain level of incident energy. It is important to select PPE that provides adequate protection without being unnecessarily heavy or cumbersome. Fifthly, after selecting the PPE, it is important to develop safe work practices to minimize the risk of arc flash incidents. These practices may include energizing equipment before working on it, using insulated tools, and maintaining a safe working distance from energized parts. Sixthly, Regular training is essential to ensure that electrical workers understand the hazards of arc flash and know how to protect themselves. Training should cover topics such as arc flash awareness, PPE selection, safe work practices, and emergency procedures. Seventhly, it is essential to review the arc flash analysis periodically to ensure that it remains accurate and up to date. Changes to the electrical system, such as the addition of new equipment or modifications to protective device settings, can affect incident energy levels and require adjustments to PPE requirements and safe work practices. The benefits of performing an arc flash analysis extend beyond simply selecting the appropriate PPE. It can also help to identify potential hazards in the electrical system and guide the implementation of measures to reduce the risk of arc flash incidents. These measures may include upgrading protective devices, improving grounding systems, and implementing arc flash mitigation technologies. One critical aspect of electrical safety is understanding the difference between the estimated guidelines provided in tables and the more accurate results obtained from an arc flash analysis. The tables are designed to be user-friendly and provide a quick reference for selecting PPE based on common electrical tasks and voltage levels. However, they are based on certain assumptions about the electrical system and the working conditions. These assumptions may not always be accurate, which can lead to either underprotection or overprotection. Firstly, an arc flash analysis, on the other hand, takes into account the specific characteristics of the electrical system, providing a more accurate assessment of the potential arc flash hazard. This allows for a more tailored selection of PPE, ensuring that workers are adequately protected without being burdened by unnecessary equipment. Secondly, the choice between using the tables and performing an arc flash analysis depends on several factors, including the complexity of the electrical system, the potential for arc flash incidents, and the resources available for conducting the analysis. In situations where the electrical system is relatively simple and the potential for arc flash incidents is low, using the tables may be sufficient. However, in more complex electrical systems or in situations where the potential for arc flash incidents is high, an arc flash analysis is strongly recommended. Thirdly, it is important to note that the notes accompanying Table 130.7 serve as an integral part of the safety guidelines. These notes provide additional information and clarification on the requirements for specific tasks and hazard levels. They often include specific instructions on the type of PPE that must be used, as well as any additional precautions that must be taken. Failing to heed these notes can result in inadequate protection and increased risk of injury. Firstly, the double-layer switching hood is specifically designed to provide enhanced protection against the intense heat and pressure waves generated during an arc flash. The two layers of material provide an additional barrier, reducing the amount of heat that reaches the worker's face and neck. Secondly, the hood also helps to protect the worker's eyes and ears from the harmful effects of the arc flash. Thirdly, in addition to the double-layer switching hood, other types of PPE may also be required when working on energized panel boards. These may include arc-rated clothing, gloves, and face shields. The specific PPE requirements will depend on the results of the arc flash analysis and the hazard level associated with the task. The voltage range of 240 volts to 600 volts is a common voltage level in many industrial and commercial facilities. It is used to power a wide variety of equipment, including motors, lighting systems, and heating and cooling systems. Working on energized equipment at this voltage level presents a significant risk of electrical shock and arc flash. Therefore, it is essential to follow safe work practices and use the appropriate PPE to protect against these hazards. Arc flash incidents can have devastating consequences, resulting in serious burns, permanent disabilities, and even fatalities. In addition to the human cost, arc flash incidents can also cause significant property damage and disrupt business operations. Therefore, investing in electrical safety is not only a moral imperative but also a sound business decision. Implementing a comprehensive electrical safety program that includes arc flash analysis, PPE selection, safe work practices, and regular training can help to prevent arc flash incidents and protect workers from harm. This program will improve worker safety and reduce the risk of costly accidents and downtime. The phrase hazard risk category 2 asterisk highlights the importance of understanding the different hazard levels associated with electrical work. Each hazard level corresponds to a specific set of PPE requirements and safe work practices. It is essential to correctly identify the hazard level before beginning any electrical task to ensure that the appropriate precautions are taken. Arc flash mitigation technologies are designed to reduce the severity of arc flash incidents. These technologies may include arc flash relays, current-limiting fuses, and arc-resistant switchgear. By reducing the amount of energy released during an arc flash, these technologies can significantly decrease the risk of injury to workers. Grounding systems play a critical role in electrical safety. A properly designed and maintained grounding system can help to prevent electrical shock and reduce the risk of arc flash incidents. It is essential to ensure that all electrical equipment is properly grounded and that the grounding system is regularly inspected and tested. Insulated tools are an essential part of PPE for electrical workers. These tools are designed to prevent electrical shock by providing a barrier between the worker and energized parts. It is important to use insulated tools that are rated for the voltage level being worked on and to inspect them regularly for damage. Maintaining a safe working distance from energized parts is another important safe work practice. The safe working distance will vary depending on the voltage level and the potential for arc flash. It is important to consult the arc flash analysis to determine the appropriate working distance for each task. Energizing equipment before working on it is the safest way to prevent electrical shock and arc flash incidents. Whenever possible, electrical equipment should be de-energized and locked out before any work is performed. Lockout/tagout procedures should be followed to ensure that the equipment remains energized while work is in progress. Emergency procedures should be in place to address arc flash incidents. These procedures should include instructions on how to evacuate the area, provide first aid to injured workers, and report the incident. Regular drills should be conducted to ensure that workers are familiar with the emergency procedures. Electrical safety is a continuous process that requires ongoing attention and commitment. By staying informed about the latest safety standards and technologies and by implementing a comprehensive electrical safety program, facilities can create a safer working environment for electrical workers and prevent costly accidents. Understanding the specific conditions of a task is paramount in determining the appropriate level of protection. Factors such as voltage, current, and distance from energized parts directly influence the potential severity of an arc flash event. Therefore, a generic approach to PPE selection based solely on voltage ratings may not provide adequate protection in all situations. The arc flash analysis helps quantify the incident energy. Incident energy is the amount of thermal energy that a worker would be exposed to during an arc flash. This value is expressed in calories per square centimeter. The arc flash analysis takes into account the various parameters of the electrical system to determine the incident energy at a specific location. The PPE is rated based on its arc thermal performance value. The arc thermal performance value, or AP, is a measure of the PPE ability to withstand the heat of an arc flash. This value is also expressed in calories per square centimeter. The PPE should have an AP that is equal to or greater than the calculated incident energy to provide adequate protection. The goal of arc flash protection is to minimize the risk of burns to the worker's skin. Burns are classified into different degrees of severity, with first-degree burns being the least severe and third-degree burns being the most severe. The PPE should be selected to prevent second-degree burns or worse in the event of an arc flash. An arc flash analysis provides a more accurate assessment of the risk compared to relying solely on the prescriptive requirements of safety standards. Prescriptive requirements are general rules that specify the type of PPE to be used for certain tasks. While these requirements can be helpful as a starting point, they may not always be appropriate for specific situations. By performing an arc flash analysis, the electrical engineers can identify potential hazards and select PPE that is specifically tailored to the task. Regular review and updates of the arc flash analysis are essential to ensure its continued accuracy. The electrical system may change over time due to modifications, upgrades, or changes in operating conditions. These changes can affect the incident energy levels and require adjustments to the PPE requirements. Therefore, it is important to periodically review the arc flash analysis and update it as necessary. The frequency of review should be based on the complexity of the electrical system and the likelihood of changes. Consider the experience and training of the personnel performing the work. Workers with more experience and training may be able to perform certain tasks more safely than those with less experience. They may also be better able to recognize potential hazards and take appropriate precautions. In such cases, it may be possible to reduce the level of PPE required. However, it is important to carefully consider the risks and benefits before making any changes to the PPE requirements. The analysis should also consider the potential for human error. Even experienced workers can make mistakes, especially when they are tired or under pressure. Therefore, it is important to implement safe work practices that minimize the risk of human error. These practices may include using checklists, performing peer reviews, and providing adequate supervision. The ultimate goal of electrical safety is to protect workers from harm. By performing an arc flash analysis, implementing safe work practices, and providing adequate training, facilities can create a safer working environment for electrical workers. This will reduce the risk of injuries, fatalities, and property damage. The benefits of electrical safety extend beyond the workplace. Workers who are safe at work are more likely to be safe at home and in the community. By promoting electrical safety, facilities can contribute to a safer society for all. Firstly, the process of performing an arc flash analysis often involves specialized software tools. Secondly, these software tools utilize complex algorithms to calculate incident energy levels based on user-provided data about the electrical system. Thirdly, the accuracy of the analysis depends heavily on the accuracy and completeness of the input data. Therefore, it is crucial to ensure that the data is collected and entered correctly. Fourthly, the software tools also provide features for generating reports and documentation that can be used for training and communication purposes. Fifthly, when interpreting the results of an arc flash analysis, it is important to consider the limitations of the software and the assumptions that were made during the analysis. The results should be used as a guide for selecting PPE and implementing safe work practices. However, they should not be treated as absolute values. Sixthly, the selection of PPE should be based on a comprehensive assessment of the risks and hazards associated with the task. The arc flash analysis provides valuable information that can be used to inform this assessment. However, it is only one piece of the puzzle. Finally, the arc flash analysis should be performed by a qualified electrical engineer. A qualified engineer has the knowledge and experience to accurately assess the risks and hazards associated with electrical work and to select the appropriate PPE and safe work practices.